Hi there, welcome back to my channel, and in this video I'll be taking you through limits of transcendental functions. In our previous lessons we've tackled limits of rational functions, we've also tackled limits of piecewise, constant, stepwise, and other types of functions. So if this is the first time you've been on this channel, kindly subscribe to support and please watch this video to the end. I have three problems here to illustrate this concept to you, right? But before then, let me take you through some special limits of our transcendental functions, okay? So first of all, what are transcendental functions? So transcendental functions, okay, transcendental functions are functions which are not algebraic, okay? But these functions normally falls under the category which are exponential. We have logarithmic, right? Logarithmic. We also have the trigonometry, okay, trigonometry. So trigonometric functions, right? Yeah, we have inverse trigonometric functions and hyperbolic functions. They're all falling under transcendental functions, okay? And we treated them in our previous videos for the introduction to functions, okay? So now, what are the special transcendental function I'm talking about? So for the special transcendental function I'm talking about, well, I mean that we have whenever they give you the limit as s approaches negative infinity of an exponential function, the answer is always 0. That is the first one. Why? Now, let me put the proof inside a bracket. The proof is that you get e to the power negative infinity, right? When you put your negative infinity here, and this is the same as 1 over e to the power of infinity. Is that not it? And this gives us 1 over what? Infinity, okay? And obviously any finite number over infinity is giving us what? 0, okay? So that is the first proof. The second one is limit as s approaches positive infinity, right? Of what? E to the power x is always equal to what? Positive infinity. Why? This is because e to the power of positive infinity, obviously the exponent to the power of positive infinity is obviously equal to what? Positive infinity. So these two have to put them in mind. Okay, you have to put these two in mind. It's very necessary. Now let's see the third one. Now let's try natural log. Okay, so limits as a natural log x approaches 0 positive of any natural log x. Okay, so let me do mine this well. So limits, right, as x approaches positive 0 of natural log x is always equal to positive infinity. Sorry, negative infinity. Okay, so take note of this too. The limit of natural log of x as s approaches positive of 0 is always equal to negative infinity. So this is something you should put in mind. Then you have the last one to be limits as s approaches what? Infinity, right? As s approaches infinity of positive infinity of natural log of x is always equal to positive infinity. It's always equal to positive infinity. So take note of all this, okay? Take note of all this. Then we'll be applying them. So without wasting my time, let's solve the problems here. So let's take the first problem, okay? Let's take the first problem. Limits as x approaches negative infinity of the expression e to the power negative x to the power 4, right? Plus 3x squared minus x, right? So for this one, so let's see. So let's solve this. When you have such a limit, right, I always say that to find a limit, first of all, you need to find a functional value, right? So if the functional value of a limit exists, then it means that the limit also exists and it exists at the functional value. But a case where the functional value is undefined, then it means that there is a discontinuity, and hence we should find our limit separately by taking parts, or by taking part. This is the word part, okay? Yes, by choosing values for what? X, or you can also reorder our what function to remove the what discontinuity, okay? Yeah, the taking part is normally used in multivariable, right? So when you have calculus and with several variables, or a function with several variables, you realize that that is where you apply the part very well. So in this case, what do we do? So first thing, when you get an exponent this way, please factorize the largest power out, okay? So the first thing to do is you just take limit as s approaches negative infinity of e to the power negative x to the power 4 out, right? So you take this one out. When you take it out, what are you getting? This one will be what 1, right? Plus what? This one will be what 3, even negative, right? Yes, negative. I'm taking negative out. So we'll be having negative here. So negative 3 over what s squared, then here will be plus 1 over s cubed, right? Yes. So once you get something like this, obviously you know that when you put infinity at this side and this side, they will give us a 0. Is that not it? Because any number over infinity, when you put this infinity, so we automatically clear that off. So you get x approaches negative infinity of the expression e to the power negative x to the power 4 multiplying 1. This is what you get, because 3 over s squared, when you put negative infinity at the s squared position, the whole expression turns 0, because you have a finite value over what? Over infinity. Likewise, this side, 1 over infinity cube, so it will be 0. That is why we are taking only the 1. Hence, we are getting limit as s approaches what? Negative infinity. E to the power, now we put our infinity there, negative infinity. So we have negative infinity to the power 4, right? So what are we getting here? So you realize that this itself, the negative infinity side, when I take the fourth power of it, I'll get a positive, right? So I'm going to get this side, I'm going to get e to the power negative infinity. That's all. Because this will give me positive infinity. So that when it multiplies the outside negative, I'll simply get negative infinity. This is the same as 1 over e to the power infinity, and this is the same as 0, right? This is the same as 0. So our first solution, our first problem given us was 0. Let's try the second problem. So for the second problem, let's see what you have for the second problem. So limit as ln x plus 1 over x as x approaches positive 0, right? So limits as x approaches 0 positive of what? Ln x plus 1 all over x. So let's analyze this one and see how we can solve this problem. So this limit of what? Transcendental function, and this function is what? Logarithmic function, as well as what? A rational function, right? So it's a rational function having its numerator to be what? Having its numerator to be a logarithmic function. Okay, so how do we solve such a problem? So to solve such a problem, we apply the properties of what? Limits. You know that when you have limits of what? F of x, right, multiplying what? G of x, right, knowing that f of x has a limit L, this has a limit, let's say L prime, then the limit of their product is simply L times what? L prime, right? So let's apply this property of limit from our initial what lesson to the introduction of limits. I took you through the concept of what? Limit and the property. So this was one of the properties. So here I can decompose this function as a product of two different functions, right? So this will give me what? Now, one may ask, why am I straight away decomposing? The reason is that when you put 0 here, so let's always try the functional value. So let's see, you're going to get ln what? 0 plus what? 1 over 0. This is what? Undefined, right? This is undefined and probably indeterminate, right? For that reason, we don't accept this. That is why we are trying to what? Modify this so that we can find a limit, right? Because at the functional value, this function is what? Undefined, right? So let's see. So let's solve this well. Yeah. So what do? As I said, we decompose this function into two. So you're going to have limit as x approaches 0 positive of ln of natural log of what? X plus 1 as a single times limit as x approaches 0 positive of what? 1 over x as also another. So the product should give me the final limit. Okay. I hope you remember this. You remember that the limit as s approaches 0 positive of a natural log of x plus something or x is giving us negative infinity from initial properties here. So when we started, I showed you a property here that the limit as, so this is the property I showed you. So the limit as ln x, the limit as x approaches 0 plus, right, of ln x is equal to negative infinity. So this is where we are applying this. Take note of this. So make sure you take note of these properties, okay? So let's see how we solve the other one. Yeah, so at this point, you know that this is simply going to give us what negative infinity, remember. So this is the same as negative infinity. Then what about this limit as s approaches positive 0 of this? You know that we simply have what 1 over what 0, right? Then any finite number over 0 will give us infinity. Okay, so we are going to get negative infinity times positive infinity, and obviously we'll be getting what negative infinity as our solution. Let's look at our third problem. So our last problem is saying that we should find limits, right, as x approaches negative infinity of the expression natural log of x minus 1 absolute of that plus e to the power x, right, plus e to the power x. Okay, so now how do we solve such a problem? How do we solve such a problem, right? So to solve this problem, first of all, you know that we have two different types of function here. This logarithmic function and this is exponential function, right? So for us to find the limits, now you can test for the the functional value, right? But without wasting my time, just go straight to apply the properties of limits. So what is that? If you have limits, right, of f of x plus g of x, right, like this is the same as you can take the limit of this separately plus the limit of this separately. So limit of what? F of x separately plus limit of g of x separately. So this is what I'm talking about, okay? So right now I can decompose this and I'll get limits as my natural log of the absolute of x minus 1 as x approaches negative infinity plus limits as x approaches negative infinity of e to the power x, right? So what will this give me? Now you know that absolute means that whatever enters becomes what? Positive, right? Yes, so whatever enters becomes positive. So meaning that my natural log of this will give me natural log of what? A positive infinity. Is that not it? So let me show you here. I'll have natural log of what? Negative infinity minus 1 absolute of that. Then plus here I'll get e to the power negative infinity. You remember these two? E to the power x of x as approaches negative infinity is always 0, right? So this here, natural log here, because absolute, you are getting natural log of what? Positive infinity, right? Plus what? This is 0, right? Because 1 over infinity will be 0. Then this one, natural log of what? Positive infinity. You are getting what? Positive infinity as well. So therefore, our limit is simply equal to positive infinity. Thank you for being with me in this video. Don't forget to like, subscribe, then share.